Okay, welcome everybody on our third edition of C++ London Uni course. Just a few words today, only today. I will take a little bit more of time. Otherwise, I will pass to Tristan or Ollie or another, teacher, which will be have much more important stuff to tell you than me. So my name is Tom Breza. I started this group pretty much almost a year ago. With goal to help myself and people like you to learn. We're very welcome to people who are from they are disadvantaged users. For example, you're on low income or you're disabled, and you basically want to change the career. Yes. Because of that goal, we decided this course should be completely free. We're not charging you anything. These guys are amazing. They are the real heroes. They actually make this happen. Thanks to Ollie, we have this space. Sometimes we use as well. Most of the time we're trying to use Skills Matters, but if Skills Matter is busy with commercial booking, they can't give us space. Mimecast kindly allow us to get this space, and as you can see, pizza and drinks, which is amazing. So obviously, very big thanks to these guys, the real heroes. Obviously, thank you for Mimecast hosting us. Couple of things, because this is a new. Most of the people I can see here are new people. There are some or old students we had before. This meetup, generally speaking, is a weekly event. So every week, and so far for almost a year, we managed to keep to that. Every year there is a class. Yes, but there is a change. Those who've been on the previous courses, they will notice this immediately. We decided to change the format. The last course which we ran, it was going very slow, and we noticed that the reason why it was so slow because of the exercises. Yes, exercises are pretty much the most important part of the course, because without this, we tell you something, you think that is amazingly simple, no problem at all. You go home, and then you have no clue what to do. So obviously, the exercises are the key. So what to do? So we decided in this edition of the course to split the course in two parts. Part one, which is today, and it will happen always on Tuesdays, it's a lecture. So Tristan or other teacher will tell you about all about what we want to pass, the knowledge, with very little of exercises during that time. But then on the following Thursday, so in 2 days' time, there is less formal meeting, yes, which we call a workshop, which we try to find somewhere space. This one will happen. Costa opposite the Skills Matter is on the details are on our website. Please do RSVP. Why? Because we are asking experienced developers to commit their time, yes, as well, and join to that meeting. So if you're struggling with something, somebody else will come in and point you, give you a hint, so basically help you with the exercises. But as you can imagine, we're not paying these guys anything. So as you can imagine, they will not take kindly. They arrive and there's nobody there. So we want to tell them, okay, there's 5, 10 people, what have you. So they know that if they commit their time, there is somebody there on the other end waiting for them. So how do you need to book the classes? If you look on our website, which is cpplondonuni.com, most of the time there will be two sides. Skills Matters, and that could be most of the time lectures. Sometimes there will be workshops. RSVP on their website. Yes, because they need to make sure that you are allowed into the building. Yeah, so if the meeting is on Skills Matters, RSVP with them. If the meeting is in place like Mimecast or King Office or somewhere else, or even a Costa, RSVP on our website, because for here we have to print the badges, otherwise the insurance people will not let us into the building. If it's on Costa, so we can obviously pass to the developers that somebody, 5 people, 10 people is coming, so they will bother showing up. If you want any updates, please do follow me on Twitter. My handle is xxvms, or you can just look for the CPP London Uni, and it's very simple. Everybody already forgot it. Additionally, we use a program for our software development called Semicolon. You can download this for free for 30 days on JetBrains' website. But if you continue coming to us, send me an email with your name, with in a subject with Semicolon license, and in body of the email put your name, your surname, and your email address, and I will send you back the license which you can use for 6 months. The product normally is commercial, it costs something like 70, £80. So JetBrains kindly gives this to our students for free. So at some point, if you need it, email me and I'll get you the license. Please do, just checking on my notes, please make sure that you RSVP as quickly as possible as well. I forgot to add that, because places like Skills Matters, if they see lots of people coming in, they give us a bigger room. Huh?
So, with regard to RSVPing, that's my place. You can always RSVP on our website, and we will always send you to the correct place. So, for example, if you RSVP for today's event, there was nowhere else to go. We always put up the Skills Matter ones as well, and if you RSVP with us, it will display on the page and send you an email saying, click this link, you need to go and RSVP with that building as well. In this particular case, you didn't. Please do RSVP wherever you're at. There was a few of you who didn't RSVP today, and it's not obviously that bad. We can sign a small number of people in, but obviously it's much easier and smoother for us if you can RSVP. We can have your badges printed in advance. That's it.
Okay. Now, one of the final things, when we leave, please make sure the room is spotless clean. Yes, obviously we want to be allowed to come back. If the room is not clean and so on, we might get, a wild card and they will say no more. So please do keep the room clean. Finally, something which someone will not be very happy for me to say, we are running a Gofundme page. This is for our teacher. Tristan laptop, which he's using to create the slides for us to teach, died, and we're collecting money for him to get the replacement. So if you feel like it, it's not a request. It's a kind pledge to you. If you think you support our project, you like the idea, you benefit from that the most obviously, please do support, and we can get the replacement for Tristan. So pretty much from me, that's all. The final thing which I would say, after the class, everybody is welcome to go with us to a pub, Bierschanke, for a couple of beers, continue to talk about C++. And if we do, it's a very nice tradition that students buy these guys a pint or two, as a way of saying thank you from you. So that's all from me, and I'm passing you to Tristan.
Oh, wow. Feel under pressure now. I never got a round of applause at the start.
Yes!
Yes.
That was for me.
Yeah, okay. Well, welcome, everybody. This is C++ London Uni. You're in the right place, I hope. So I'm Tristan, and this is Initial C++. This is the beginning, this is the start. So this session's going to be a little bit different to how the rest of them go, just because we're right at the beginning. But before that, a couple of things to get out of the way. First of all, this slide is left here from last time. I guess if you're all like beginning C++, it's probably a bit early to start going to conferences, but we have people who are watching online. And this is a conference, it's a new conference, it's starting, it's in Kent in February. It's run by a friend of ours. So if there's anybody watching online, really recommend, go and have a look at their website. Think about registering for the conference, it's going to be great. And there you go, that's my advertising piece done. All right. About these sessions. So who has been to one of these before? I recognise a few of you, quite a few of you. Giacomo, you haven't been for months. Nice to see you back, though. Fair enough. Good to see you back.
That's a valid excuse.
Yeah. All right, so these sessions are an introduction to C++. Right. And the format we use is it's a mixture of talks, exercises, homework. So despite what Tom was saying, there will be some in-class exercises, but they're just little small tasks just to get you practicing with a piece of syntax or something like that. Okay. After every class, at the end of every class, I'll aim to set some homework. And this will typically be on things that we've learnt in that class, and then often at the end I'll put in a little extension for people who want to go further and read on. And in particular, the extension ones are meant to be a bit more challenging. You know, they're not something that, well, if I've got it right anyway, are not something that will necessarily be easy. But the idea is that we run these sessions on a Tuesday, and you listen to me talking, and you do a little bit of practice. And then on the Thursday, hopefully, a lot of you will be able to get together and have a crack at the homework in an environment where, you know, you can all talk to each other, learn from each other. Hopefully we'll have a couple of more experienced people there for when you run into real problems and need an explanation. Because there's, I'm sure you've heard this, right? There's this famous theory that it takes 10,000 hours to become an expert at something. You heard that? Yeah. So 10,000 hours, that's about 5 or 6 years of full-time work. So if we have 2 hours once a week, 50 weeks a year, because we have a couple of holidays, that would be 100 years of just doing these sessions, right? So that's not really practical. We can't turn you into an expert just in these sessions. Programming, like anything, if you want to be good at it, the only way to get good at it is by writing programs. It's like learning to play the piano. You know, you can have your piano teacher, and your piano teacher will, you know, give you tips and show you how to play this particular key or this scale or whatever it might be. But if you don't go home and practice, you're not actually going to get any better at playing the piano. And that's what it is. That's the way it is with programming as well. So we'll try and guide you, but it requires practice as well. So that's the idea behind these new Thursday sessions that we'll bring in, and I'd encourage all of you to sign up to those. So yes, we can't turn you into an expert, but we will try and give you enough information in these sessions on Tuesday to get you started. And I don't know if anyone's seen this cartoon. It's quite a famous one, at least famous in C++ circles. There's a textbook out there. Get it on Amazon if you ignore the reviews. It's Teach Yourself C++ in 21 Days. This, you can read it on the slides later if it's too small on the screen. It's basically just saying there is no way to teach yourself C++ in 21 days. You just have to practice with it, get better at it, try out new things, try out new skills, develop your skills. And that's the way to get good at this. Okay, a little bit more about the course. We are sort of trying out a new format. Because as Tom says, we've been doing this for nearly a year, but we're trying out something a bit different. The reason for that is we've had people who keep coming, and that's great. And they want to get on, and they want to learn. You know, they've learned the basics. They want to learn the more advanced stuff. It's understandable. But we also have a lot of new people who come in. And if we're sort of 15 weeks into the course, they sit there on their first time and they scratch their heads and go, what on earth is going on? This is awful. So we're trying hard to sort of strike a balance between doing these sessions, allowing new people to come along, but also mixing in more advanced material for the people who already know the basics. So what we're doing is we're trying to break the course up into smaller shorter modules. So what I mean by that is we'll have sort of 4 to 8 weeks of these sessions on a particular topic, particular subset, if you like. And after we've reached the end, we'll have a module test. We've had a couple of them so far, and those are for you to gauge how well you know the material, but also for us to gauge basically how well I've done with this stuff at the front, right? what do I need to change? What do people find really easy and I can maybe go over more quickly next time? What do people struggle with that I need to go into more detail? So this is what we're trialing. And this is the first time we've done the initial stuff in a sort of modular way. So I've decided this one, I'm going to call it Initial C++. C++ 101 if we were a real university, which we're not, by the way. If anyone was expecting to get like a real degree, I'm sorry. You can call me professor though if you like. So this module is Initial C++. And in particular, we're not assuming any prior C++ knowledge here. If you do have some programming knowledge, that will definitely be a help. If you have no programming knowledge whatsoever, well, then you're going to require a bit more practice. It should still be possible to follow the course, but you're probably going to have to use some other resources, textbooks or online or what have you. So just actually on that note, I'm quite curious to know who already knows a fair bit of C++? Who has used C++ before? Oh, quite a few of you. Okay, you're going to be really bored today. Sorry. Who has not used C++ but is already sort of quite familiar with another programming language, like Java or Python or whatever? Okay, so what kinds of languages? Just yell some out. Java? JavaScript? JavaScript, Python. Sorry? JavaScript. Perl. Who said Perl? Oh dear. Right, well.
Negative opinions of Perl here. Judgment.
No, Perl is amazing because it looks like line noise, and then that's just a regex that does the most incredible thing in no time at all, and I don't understand how it works. So I'm always very impressed by Perl people, but also slightly scared at the same time. But people say that about C++ as well, so I. Anyway, so yes, if you have some prior programming experience, that will be a help for this. So, and who has never written a computer program in their life? Okay, 3 of you. Okay, so you guys, hopefully today will be okay. But as we go on, you might kind of think, "Whoa, what's going on here?" If that's the case, then by all means, come and talk to us. Come and ask questions. We'll do our best to help you. I'd recommend getting a textbook. This one's really good. This is the one we recommend. This is it's called Programming Principles and Practice Using C++. It's by Bjarne Stroustrup, who actually invented the C++ language. This is a really good book, not just for teaching you C++, but as a sort of introductory guide to programming. So, sorry? I should have put it up on a slide, really. It's called Programming Principles and Practice. I'll leave it at the front, and if people want to have a look on the way out. It's quite a weighty tome. I think it goes for, it's about £30 on Amazon, something like that. There are
when you buy, we'll change the book next time.
There are ebook versions available as well that are cheaper. Okay, that's gone. Okay. Last little introductory slide. Just note about feedback. So we like hearing from you. We like knowing what we're doing well, what we're doing not very well. There's in particular, if you want to email, if you want to keep things, if you want to tell us something in confidence, and email. Otherwise, we really recommend going on Slack. So Slack's a chat program heavily used by programmers. We have this CPP lang group, or rather the CPP language has its own group. And we have our channel on there, CPP London Uni. So really recommend everyone goes and joins that, because that way you can talk to us, you can talk to other students for the 5 or 6 days a week that we're not meeting. Okay, so it's technically invitation only, but if you go to this URL, you can just pop your email address in there and it will send you an invitation. It'll send you an invitation to join and then you can. There's an app you can download, or you can do it via in your web browser. So, recommend if everybody can join that. That would be awesome. Because we also pop announcements on there as well as via email. I'll leave that up for a second.
Probably also mentioned the CPP line. Slack is now owned and sponsored by the C++ Alliance.
Yes. Yes, so if anybody had joined this previously and was bothered because there used to be this limit, we were using the free version of Slack, which had a limit on how long it kept messages. So anything older than about a week disappeared. But now it's been sponsored by this new group called the C++ Alliance, and their mysterious funding, wherever it's coming from. But anyway, they're now paying for the commercial version of Slack, so that's nice. So there's now history going back forever. So that's good.
It's coming from Billy.
Yes, but where's he?
Bitcoin.
Oh, okay. Right, well, there you go. Cryptocurrency in action. Yeah. Cryptocurrency paying for this. Does that mean it's going to crash in about a week? And
No, Vinny used to work for Ripple. So he was big in Bitcoin, he worked for Ripple.
Yeah.
And now he's just retired and wants to keep he wrote Beast, obviously, at Boost.
Anyway. Okay, so hopefully everyone's got that. Otherwise, I'll put it on the slide at the end. So today's lesson plan, this is what we're going to aim to cover today. So we're going to have a little introduction to C++, just a little bit of me talking about it. And then we're going to look at Hello World, because it's sort of a rule that whenever you look at a new programming language, the very first program you have to write, you have to look at, is one that prints Hello World on the screen. It's like the law, right? And if I don't do that, like someone is actually going to come and arrest me. So I don't want to be arrested, so we're going to do Hello World. And then we're going to look at types, what a type is, why they're important in C++, and then we're going to have a look at how we write functions. So that's the plan. Does that sound good? Good, because we've locked the doors and you're stuck. All right. So let's talk about C++. You're all here, presumably, because you want to learn C++. But why? Why do people use C++? That's not rhetorical, this is a question. Why do people use C++?
Speed.
Speed. Fast.
Scalability.
Scalability, I like that one.
Control of your hardware.
Control of your hardware. I'm going to boil it down to the very first one because I like that. People use C++ usually because it's fast. Because programs you write in C++ execute quickly, hopefully, and don't use too much memory, hopefully, and make efficient use of resources. So why is it fast? On the one hand, it's fast because it offers a direct access to hardware. It has all these nasty pointers and things that C has. You can, if you want to do manual memory management, you can really, really go down to the low level and do, you know, bit twiddling and raw memory if you really want to, right? If you really, really want to optimize, C++ is great for that. It can do everything C can do. Yeah. Gives you a direct access to your hardware. What C doesn't give you is these zero overhead abstractions. So what do we mean by this? What do I mean by this? I mean we can create functions, classes that wrap all this nasty low-level pointers and raw memory and stuff. They can wrap it up in classes that are nicer and easier and safer to use. But that when you compile it, when the optimizations happen, all these abstraction layers go away. And all you're left with is the same machine code that you would have written by hand before. Right? So you can use these nice, safe things like vector, like unique pointer. And when you compile a program, all that overhead goes away. And you end up, hello. Oh, goodbye. When you compile your program, all that goes away. And you're left with code that's just as fast as if you'd written it, in a really nasty way. C++ offers efficient resource usage. So in terms of memory management in C++, things go away, memory gets freed as soon as you finish using it. Right? There's no garbage collector in C++. Stuff doesn't hang around in the ether for an indeterminate amount of time until something else comes along and deletes it for you. When you're finished with something in C++, it goes away. And that doesn't just go for memory, it goes for things like file descriptors, network sockets, whatever it might be. Right? We make very efficient use of resources. So that's what makes C++ fast. And as a result of it being fast, it's used everywhere. So everything from tiny little embedded systems. I mean, I don't know that this is running anything written in C++, but it wouldn't surprise me. All the way up to, the world's most powerful supercomputers. C++ is used everywhere. Just some examples off the top of my head. Games, if you've ever, probably every single PlayStation or Xbox or whatever, every mainstream game you've ever played was probably written in C++. It's heavily used in the financial industry, banks, hedge funds, that sort of thing, high frequency trading, all want this fast property that C++ has. Lots of applications on your machine. You've probably got a web browser open on your laptop now. Whichever one you use, it's almost certainly the majority of the code is C++. Chrome, Safari, Microsoft, whatever it's called now, Edge, Firefox, they've all got tens of millions of lines of C++ in there.
It's also used for web security. Shameless plug for Minecraft.
Yes.
Well, not really. C++ in Minecraft.
So it's used everywhere, it's really fast, it's been around for a very long time, C++ is brilliant. Well, I'm obviously going to say that, right? Because I'm trying to get you guys hooked. But I suppose I have to be honest, other programming languages do exist, and from time to time people use them. So we have to ask the question, why not C++? If C++ is brilliant, why is it not used everywhere? And the honest answer that you might have heard is because it's hard, right? It's difficult. It's a big language. It's tricky. It's there's lots of corner cases. This is somewhat true. I mean, I have to come clean and be honest with you, right? It's not the easiest programming language to learn, partly because it's so powerful. Because it's been around for a very long time, it's accumulated, some decisions maybe made in the 80s that turned out not to be so great, but we're stuck with them now. It's a very big language. You can do lots and lots in C++. Do imperative programming like C, you can do object-oriented programming. You can do generic programming. You can sort of do functional programming, right? C++, part of what makes it so powerful is because you can... Okay, can you fix that, Justin? Okay. I've completely lost my train of thought. What was I saying? Yes, C++ has lots of features, very big language, so if you want to learn everything, then that takes a while. And yes, as I said, it's been around for a long time. It's accumulated lots of, or a bit of cruft. But as we're going to see, later revisions to the language have really cleaned this up and made things much better. So it's not that hard. It's harder to get started than, say, Ruby or Python, maybe. But once you've got there, once you've got a good idea of C++, then you pretty much already know C. Changing to, you pretty much already know Java, syntax-wise at least. Right? See, learning C++ is a bit like learning Latin. It's harder. It's harder than learning Italian or Spanish. But if you learn Latin, then learning Italian or Spanish or whatever it might be is going to be a much easier job. Right? I don't know if that's selling you it or not.
Where are these slides?
They're on the screen.
No, are they online?
They will be, yes. They're not yet, because I like people to watch that rather than downloading them and scrolling ahead. So I don't put them online before, but they will be afterwards. Yeah, so it's not that hard. Learning Latin's not that hard, right? Anybody do Latin at school? Oh, quite a few of you, actually. Yeah. See? Not that hard. Maybe. All right, let's have a very, very brief history of C++. So, 1979, this Danish guy, Bjarne, apologies to any Danes in the audience, by the way, I'm probably horrifically mispronouncing his name. He started working on something he called C with classes, so the C language had already been around for a few years by then. And he started working on a set of extensions to C that he initially called C with classes. And then about 1983, these extensions had gone past just the object-oriented classes stuff, and the language got renamed C++. Then in 1990, so by the way, 1979, this language is older probably than a lot of people in the room, which is kind of weird, right? It's older than me. So yes, 1990, the ISO, the International Standards Organization, formed a committee to define what C++ is. So this is something that's not very common these days, but in the 90s, if you wanted your language to be used by the US government, which was a very big deal, it had to be standardized. So there was a C committee and a C++ committee and Ada and Fortran and all these languages that date from that time have these committees.
And before that, he was working on that alone? As far as you know?
They probably were a team of people by then. I'd imagine he wasn't working on it alone for 11 years. I don't know. Certainly by 1983 there were lots of users, so I imagine he probably had more people working on the compiler with him. He actually wrote a book called The History of C++ or something like that, where he goes over exactly, but I haven't read it. So.
There's a talk he gave on YouTube as well that you can watch if you're more visual.
If I can't handle words.
If you can't handle the
Yeah.
for a book, yeah.
Yeah, okay, well that would probably be, I'll probably be able to answer these things with more knowledge if I actually read the book rather than just getting these dates off Wikipedia. Sorry?
It's treating you a bit like Donald Trump. I would be offended. If you cannot read it too much, you can watch a video, something like that.
Yes.
I think that'd be a stretch for Trump.
Even
Even a video. If it's longer than 2 minutes, that's it.
Oh, if it's on Fox News. Anyway, let's concentrate on C++, shall we? Right. So this committee, they worked for 8 years. And in 1998, sorry. In fact, I believe it's 20 years ago this month, they published this big 1,000-page document that defined what C++ is. And that document today is known as C++ 98. And then for quite a long time, nothing happened. And then people started, by this stage, there were a couple of million C++ programmers probably out there. It was really, really heavily used. But during the early 2000s, a lot of other languages came along, Java in particular, but C# had started around then. People started using these other languages, and C++ was beginning to look a bit dated. And so the committee got together and they started working on how can we clean up the language, how can we make it more modern, how can we add things to make it more pleasant to work with. And this was originally aimed, they said it was going to take 10 years, they were aiming for 2008. It was software, so it slipped and slipped and slipped. And eventually in 2011, they came up with this major update called C++ 11. Right, which really completely transformed the language. And since then, so that was what, 7 years ago now. Since then, things have been progressing much more rapidly. So in 2014, there was a second update, or what's that? Third update, second update, third version, and then C++ 17 was published last year. And it's expected that we'll have C++ 20, 23. So the idea is every 3 years we get a new version of the language. Now, fortunately, these changes haven't been anywhere near as major as the transition from 98 to 11. These have been incremental updates rather than sort of revolutionary updates.
Why do you say unfortunately? Maybe stable is good as it is.
Don't upgrade compiler. If you don't want to use the new version, don't upgrade.
Small fine-tuning.
Well, if they were completely redefining the language every 3 years, that might be problematic because, in particular, for something like C++, people use it for long-lived code, like code that you still want to be able to run in 10 years' time, right? Not like whatever, I don't even know, I'm so out of date, I don't even know the latest JavaScript framework, but it probably was different to the one from last month, right? Because JavaScript moves very fast, and what's the latest framework? It seems to change every week.
Yes, next.
Sorry?
It's called next.
Next. Okay. By the time this video goes out, that'll probably have changed.
Probably.
Yeah. So with C++, we aim for a bit more stability. So the balance they've struck is to come up with a new version about every 3 years, so that model seems to be working pretty well so far. So hopefully 2 years' time, C++ 20, we'll have a new version that'll have lots of new good stuff in. So in this course, we're going to be using C++ 14. I was seriously considering moving to 17, but the compilers that support 17, although all of the newest versions of all the compilers do support C++ 17, some people might still not have access to the very latest compilers. So I thought it's safer to stick with 14. Probably in 6 months' time I'll revisit that. But for this course, we're going to stick to C++ 14. So just a word about that. As I was saying, C++ 11 completely changed what C++ is. So don't bother learning C++ 98. There are still lots and lots of resources out there on the internet, lots of books you can buy that still teach you C++ 98. Don't use them, right? C++ 11 changed so many things. They made the language better in so many ways that learning C++ 98 will almost teach you sort of anti-patterns, like things that are almost bad things to do in C++ 11. Right, so focus on C++ 11 or newer. This book uses C++ 14.
Which version is that one?
This is the second edition.
Second.
Yeah. So yeah, just be careful if you're Googling things, if you're looking online, if you're looking at Stack Overflow answers or whatever it might be. Just make sure it's not too old, or you might be getting bad advice. Okay. That was my first little spiel, all about C++, all about the language. I haven't really done anything tricky yet, so I don't think there will be questions. It just felt polite to ask. Are there any questions? We're all just scared off at this point, going, why the hell? What have I done? Why am I coming to this? let's have a bit of a break. Well, 5 minutes or so. It's time for you to get your hands dirty. It's time for you to write some C++. So, does everybody have a laptop? Or at least something with access to a web browser?
A friend next to them.
Or a friend next to them whose shoulder they can look over? Yes?
So
No?
what's the Wi-Fi?
It's on the. Can you see it in the slide? It's probably not even visible.
I can't see anything on the board.
We'll use this.
So, we're going to turn you into C++ programmers. You're going to write your first C++ program. So if you go to onebox.org, if I remember rightly, it does actually come with a, if you just, the first time you ever go to the website, it does have hello world already in there. But, you know, that's cheating. So just delete that and write this, because then you can say you've written it by yourself. That's more fun, right? So if you could all have a go at this, I'll give you 5 minutes or so. Shouldn't take too long. And then we'll have a look at what this is actually doing.
So Wi-Fi here again?
On the whiteboard behind you. Hopefully you can see it because you're closer. Past the portrait picture backwards. Encouraging TN or Gore region. Code Gore. Call them Gore routines because they are Gore to actually make it.
Also, they're not even in sound.
They are TNs. Now, it's not the case on plain sound.
No, so this is the idea behind this. No, I'm sure. Yes, so this is what.
If anybody is stuck, just raise your hand, you know, and that more experienced developers will get to you, try to give you a hand.
By the way, if anybody does have any problems, just...
I just said it.
Oh, okay. Well, that's fine. I was too busy stuffing my face with pizza. It's the only reason I put an exercise in here.
The different version of C++ and use
Does it mean that if I write a C++ 11, sorry, C++ 14, that would not be compatible with anything written in C++ 11? Meaning that if I use a library that is written in a different version of C++.
That is probably something I should have pointed out. Okay, so that's a good question. So the question was, basically, is there backwards compatibility, right? If I write something targeting C++ 11, will it still work with the 14 compiler? And the answer is, yes, it will. There are a few things from C++ 98 that were deprecated and removed, but those were bad things, right? You should never use them anyway. But there is, yes, if you write something, even the overwhelming majority of C++ 98 code will still run today, will still compile just fine. And for the newer versions, that backwards compatibility story is even better. So if you write C++ 11 code today, it will still, if you have some C++ 11 code and you compile it with like a 17 compiler or even a 20 compiler, that's still going to work just fine. Yeah, so it's not like they're completely reinventing the language. They're adding stuff to it. Some old library things get deprecated and you might come up with a warning saying, use this instead because this is newer and better, but it's still going to work. I think they're saying for at least 2 versions, probably 3. So that's 6 or 9 years to change your code, so that's not too bad. It's interesting actually, Java has adopted this model of moving very quickly. I mean, they're instead of every 3 years, now they're going every 6 months, is that right? I read that somewhere. I'm looking at you because you've put your hand up as a Java guy earlier. But...
No, I don't know it that well.
Oh, okay.
Yeah, I think I started sort of same time, wasn't just doing 4 week object oriented bit. So wraps. So I don't know you've done any C++ before. Don't need programmers. Okay, yeah. So environment, yeah. So it's not going to be any harm to read it for the first few weeks. Which is something to point to. I need a refresher. But if I had been practicing on sometimes it goes off and takes you like stuff and you think, what the hell does they mind? But no, it's yeah, it's shows you, especially when you start to work in to actually understand your program or the language you'll work a lot better. This is the daddy language of the water.
See, it's interesting. You get the log, the ball log,
Oh really? What does he say? Really? Yeah.
Oh no.
And also flushes the output stream. So that's necessary. Using slash n is a better way to do it. Yeah, better habits.
Yeah, it doesn't it hasn't backed off.
Sorry,
Basically,
did you have to delete what was in the box in the practice?
Have a look at shade. Basics we don't see. You see it again.
this is almost like solidity.
Solidity.
That's a programming
Yeah,
there's a programming language for blockchain.
Shade uses GPU.
Oh, yes, it probably is. Oh, the Ethereum one. Yeah. Is that no?
No.
Okay. I thought the Ethereum had their own language for writing the smart
You may be right,
contracts.
actually.
Yeah.
Solidity is one of them.
Yeah. That would have been heavily based on C++. Yeah. So the syntax-wise, it will look very similar. Okay. Put your hand up if you've done that, and if you got something out that said hello world. Yep. Majority of people. Awesome. Okay. So we're going to have a look at what this program is actually doing. So let's go through it line by line. So line 1, // our first C++ program. So can anybody tell me what this line is? It's a comment. This is a comment. So in C++, as in most languages that are sort of based on the C-ish syntax, so things like Java and JavaScript and various others, you can write comments in two ways. You can either start with a double slash and then everything to the end of the line is a comment. Or the other way to do it is to do /*. You can write big multi-line comment, as much text as you like, and then finish that off with //. So, and if you've used a kind of C-ish programming language, that should be familiar. All programming languages have some way of writing comments. A lot of the scripting languages, you have a hash and then it's to the end of the line. This is how we do it in C++. Okay, so we're getting a bit trickier. Include Iostream. So, Iostream is a component that's part of the C++ standard library that deals with input and output, particular streaming input and output. Okay, so this hash include, we'll get into precisely what that means, precisely what it does, I think the week after next. That's the plan. But the point is, this is including this standard library component in your program. It's giving you access to these facilities. So it's a bit like if you're used to Python, you do import. Java, I think it's import as well. I can't remember that one very well. But this is saying, I want to use this bit of functionality that the standard library gives me. So the standard library is a lot of facilities written by experts that come with your compiler, that are there automatically. And you can use these, you're encouraged to use these, you should use these facilities to write your programs. So this is saying, I want to use this bit of functionality. So specifically, as I say, we'll get to precisely what this means in a bit. But this is including the Iostream header in our program. And one of the many things that's in Iostream is this facility to print to the console, the command line, the terminal, whatever you like to call it. And we use this include facility to break programs up into smaller, manageable pieces. If you had to write your entire program in one text file, things would rapidly get unwieldy, right? That would be ridiculous. You can have one 10 million line text file that you are somehow expected to work with. So we use this facility to modularize our code, to break it into smaller pieces that we can work on independently, individually. And we also use it to gain access to code from other libraries, so code that other people have written that we want to use. We use this include facility, and that's exactly what we're doing here. We're using code that comes from the standard library, the library that comes supplied with your compiler. So this is what allows us access to the print function. So next line, int main, open close brackets. A bit trickier now. You know what I'm going to ask? What does this line do? If you've already been to this class, you're not allowed to answer.
How did you know I could?
I've seen your test scores, I know you could. So what's this line doing? It's declaring the main function. That's exactly what it's doing.
Is this a return type integer?
With a return type of int. Yes, absolutely. Okay, so this is declaring a function called main. And we're saying that this function takes no parameters, so it's the empty brackets, and it's returning an integer.
Is everyone clear on what an integer is? If you're not mathsy, then maybe you don't.
Yeah. An integer is a whole number, right? So 1, 2, 3, 4, minus 10, 107, a whole number, not 3.92. That's an integer.
Why should a main function return an integer?
That's a good question. It returns an integer because C comes from it's the language was used to write Unix, and in Unix programs can have return values, right? So
What's in those?
yeah. So by convention, if your program returns 0 on Unix, that means it executed successfully, and if it returns something else, then that means there was an error. That's the convention. Okay, and there's a Unix command that I've forgotten, but it lets you see the return value of the last one, and if you write shell scripts, you can use the return value of your program. So by returning an integer from main, that lets us return this success code to the operating system. So that's what the integer return is used for. That's what the return value of main. But main itself is a very, very special function. So main is where execution of our program begins. So when the operating system runs our program, it begins at the beginning of main, and the program terminates when we leave the main function, when we return from the main function. So as I say, main is special. There are some special rules that we'll come to. But every C++ program has to have a main function. And it has to return an integer, actually. It's one of the rules. Oh.
Cable.
No.
This goes into sleep or something.
This was the next line. Curly brace. Curly brace opens a block. Blocks are pretty important in C++. And in this case, this block contains the definition of our function. So when we're writing a function, and we'll go into this in more detail in a little while, when we're writing a function, we write its name, its parameters, its return type, and then we put its definition, that is, what the function actually does. We write that in curly braces. The reason I said blocks are quite special in C++ is because they control object lifetime. They control scope, and object lifetime is tied to scope. We'll talk about that more next week. Blocks are very important. Next line. std : cout, arrow, arrow, hello world, in double quotes with a /n in there. That is a lot to go through. Let's break it down. Let's look at this bit first. So, as you probably gathered, this whole line is C++'s way of writing a print statement, which, sorry, I mean, the law says I have to do hello world first, and C++'s way of printing is esoteric, let's say. It's almost every other language just has a function called print, or printf, or println, or something like that. Not C++, we do things a bit strangely. But you don't have to understand precisely what this is doing now. I'll run through it quickly. But if what you take from this is that to print something, I do std : cout, arrow, arrow, and then the thing I want to print, that's fine. So what it's actually doing is that cout stands for console output. It's an object provided by the standard library. It's an output stream provided by the standard library that prints text to the console. It's in the standard library, and everything in the standard library is prefixed by this std : This is called a namespace. So in C++ we have this concept of namespaces. So that code I write, that I put in my namespace, doesn't conflict with code that you write, that you put in your namespace. Right? So if I write a function called, oh, I don't know, let's say print, and you write a function called print, then if we put them in our own namespaces, these things don't conflict. So namespaces are a way of separating code from different companies, organizations, libraries, whatever it might be, to separate them into their own, well, namespaces. Right? Their own sort of compartmentalize, so that these things, whatever names we pick, don't conflict with each other. So if you've written C++ before, you might have, or you've seen any examples of it, you might have seen this thing that says using namespace std. What that does is it imports all the names from the standard library and just lets you use them without having to type this prefix. And that can be quite useful in small programs, but it's generally discouraged in larger programs because, as we said, namespaces allow us to avoid name collision. And if you just import everything from the standard library, then you're asking for a conflict. Because the standard library is huge, it's got loads of really common names in it. So this can lead to this, as I say, it's all right for small programs. Something like Hello World, you're not going to have a problem. But as soon as you start writing larger bits of software, it can, it's recommended to avoid it. So I've avoided it here just because I want to try and teach you good habits. So moving on to the next part, Told you this standard cout thing is an output stream. And this double chevron is used to pass the thing on the right to the output stream. It's an example of what we call operator overloading. So this bit of punctuation in the middle, this is an operator. And C++ allows us to define what operators do. So we could write what plus does for our own types, or what times means for our own types, if we wanted to. And in this case, the people who wrote the standard library decided to use this, it's the bit shift operator actually is what it's called, decided to use this shift operator to mean pass this to the output stream. So again, if this all seems a bit weird and mysterious, don't worry about it too much right now. The only really important thing to take from this is that writing standard cout and then this double arrow is how you print things. Because C++ is weird, and this library was written in 1982, and we're stuck with it. So we're not stuck with it because C++ 20 will actually introduce a much nicer way of doing this. It will finally get to write this just as nicely as Python does, but unfortunately we're not quite there yet. So we still have to do it in the 1982 way, which is a bit unfortunate. When I said there were kind of still a few horrible warts in the language, slightly annoying that you come to one in lesson 1, but we'll work with it. We'll get past it. Finally, we have this thing, hello world, in double quotes. This is what's called a string literal. So in programming terms, a string is like a list of characters, a sentence, a paragraph, or whatever it is, some text, right? We call them strings. So this is a string literal because you haven't calculated it, you've written it directly in your program, so it's called a literal. And we put them in double quotes. So in some languages, single quotes and double quotes do more or less the same thing. As long as you match them up, that's all right. In C++, single quotes and double quotes mean different things. So when we're writing a string like this, we have to use the double quotes. Single quotes are used for what are called character literals, single characters. But in this case, we're printing a whole string, multiple characters. So we use the double quotes. And then we've got this mysterious /n thing on the end. And all that means is print a new line. So we want it to print hello world followed by a new line. And we could have put some text after it, in here. Could have said hello world, new line, and hello other worlds, perhaps. And that would have put the new line in the middle. So the /n doesn't have to go at the end. In this case, we put it at the end. But we could have put one between hello and world if we wanted to. We could have put one between every letter and it would have printed out vertically. So you can put this /n anywhere in your string, and it will print a new line right there. So this /n is an example of what's called a control code. It's the most common one. There are various others, but /n is the most common one to use. Now again, if you've seen some C++ before, you might have seen people using this endl thing to insert a new line. And that's fine, you can do that if you like. There's nothing particularly wrong with it, at least for simple examples like this. It's just that A, it's more typing, and B, it's just not a great habit to get into because endl actually does a bit more than just inserting a new line. It flushes the output stream as well, which we don't usually want. Usually we want, familiar with these things, usually you want to build up a nice big buffer and only copy it to the output stream once. Whereas using ENDL flushes the buffer right there and then. So if you do this, if you do it a lot, it can be slower. Again, for just a simple hello world, that wouldn't be a bad thing, but I'm trying to teach you good habits. And finally, we've left almost the most important thing to last, the semicolon. If you are starting out with C++, in fact, even if you've been doing C++ for years, you will forget to put this semicolon in, right? Almost all statements, well, pretty much all statements, in fact, end with a semicolon. It's like the full stop at the end of a sentence, right? It's really easy to forget, particularly if you're used to writing Python, where you don't have to use semicolons, or JavaScript, where they're sort of optional, but you sometimes have to use them, right? C++, you do have to use them. You will forget. It's not a big deal. Usually the compiler will tell you. It will say, I expected to see a semicolon here. Right? And you go, oh, okay, and you put it in. And I do this. Like, I've been doing C++ for years, and I still do it from time to time. Right? Very occasionally, and compilers are getting a lot better at this, very occasionally, it'll get very confused, and it'll start like trying to read both. You know, it's like having a missing full stop. If you're reading a chunk of text and there's no full stop, usually you can read it and make sense of it and go, oh, okay, there should have been a full stop there. But sometimes you try and parse the whole sentence at once, and you're like, well, I don't understand. And sometimes that's what the compiler does. And it will spit out a really strange error that makes no sense. Right? So if you see that, very first thing you do, very first thing I would always do, go and make sure I've got all my semicolons in the right place, because they're really easy to forget. Final line, well, penultimate line actually, of our little program, of our hello world. Return 0. So return is a keyword, C++, and in C and, well, most other languages actually. And this says leave the function. Leave the function now and pass whatever value we give it, in this case 0, pass that back to whoever called this function. Now in this case, as we mentioned, main is very special. It gets called by the operating system. So it passes 0 back to the operating system. Was your question earlier. So as I said, just by convention, if we return 0 to the operating system, that tells it our program ran successfully. We didn't have any errors.
Well, where is $question mark if you want to see the last value?
Oh, there we are. $question mark. Is that bash specific?
That's question. I think.
Okay. $question mark.
I don't know if it works in those.
Tells you the return value of the last program that you ran on your Unix terminal, if you are interested.
Trivial question.
Yeah.
Does the semicolon have to be right at the end of the line, or can there be a space?
Whitespace is in general insignificant, so you could have a space, you could have 10 spaces, and then the semicolon. You could put a few new lines and then put the semicolon to terminate that statement. Indentation is absolutely not important. No. No. You can format your code more or less however you like. You have to put spaces between keywords, or no, you have to put some white space between keywords. But that can be a space, or a tab character, or a new line, or, well, those three, actually. But no, C++ doesn't care at all about formatting. It doesn't care whether you use tabs or spaces, or how much you indent, or anything like that. It's almost completely freeform. So when I wrote this, I put the curly brace on the new line by itself. That's just a stylistic thing. A lot of people will put the opening curly brace on the same line as the function. But you could leave several spaces before the opening curly brace. It really doesn't matter. So finally, main is a very special function. Lots of things are special about it. One of the things in particular is special about it is, although we've said it returns an int, main has this special rule that if you don't write return 0, if we just omitted that line, the program would behave as if the last thing you had said was return 0. It will automatically return 0 if you don't tell it to do something else. This is a special rule that exists only for main. No other functions do this. So again, if you see any Hello World examples online that don't have this return 0 at the bottom of main, that's perfectly fine. They're not doing anything wrong because it's allowed only for this main function, no other functions. And finally, the very last line of our program was this closing curly brace. So this closed the block that we opened. It finishes the function definition. So we used a curly brace to open our list of instructions, and we use a curly brace to close that list. So everything between those curly braces is what we call the body of the function, the definition of the function. So a function is like a list of instructions to execute. And we write this list between the curly braces. So when we reach the closing curly one, the compiler knows, okay, we've reached the end of this definition. This second line is rather special. When we leave a block in C++, local variables that were defined in that block get destroyed there and then. It's what's called deterministic destructions. So I said this earlier, there's no garbage collector that looks to see, oh, well, you finished with this, I'll go along and delete it now. As soon as we leave a block, anything defined in that block, variables defined in that block disappear. And I'm going to hammer on a lot more about this next week, but this is the single best thing about C++. Really is. This is what makes it, all those benefits I spouted earlier, they all come from really this one feature. About the zero overhead abstractions and all of that. This deterministic destruction is absolutely magic, and we'll be talking a lot more about it. I'm looking at a sea of shocked faces now. Everyone was quite happy when I was just talking about abstract things. I'm showing code on the board, they're like, oh, wait, hang on. But don't worry. Things will become clear. I've shown you like the 1,000, the absolutely raced through a little program. But now we're going to go through and we're going to explain things a bit more slowly and a bit more clearly. Not everything is going to be at that pace, don't worry. How can I put this? I don't like being told, this is magic, don't worry about it yet, right? So I don't want to do that to you. Because you're all intelligent people. And I don't just want to say, this is magic, just type this, and I don't want to explain how it works. So I thought I'd give you a brief explanation of how it works. And then we'll go into a more detailed explanation over the next few weeks. And hopefully in a few weeks' time, you will have a much more thorough understanding of what I've just gone through in about 20 minutes there. Yes?
I have a question.
It's a good time for it.
So you said that you imported from the standard library the Iostream.
Yes.
It's a part of the standard library. But then we called std standard library.
Yes.
Cout. So what's going on there?
I see what you mean. Okay. Oh, gone back too far. Why have I...
Well, I guess my question was like, where's the Iostream actually being used in the program? Like,
Oh.
I don't
Okay. I'm trying to get back to the overview of the program, but I've lost it now. Sorry. Went back far too far. Right. So this is the whole program again. Okay, so this makes all the facilities within Iostream available. So Iostream is a collection of lots of different functions and lots of different types. One of them is standard cout, but there's a standard cin that reads from the console. There's a standard file stream type, for example, for writing and reading and writing from files. And so Iostream gives you access to all of these streaming facilities. We're just using one small part of that. Right, so this brings in quite a lot of facilities. We just need one of them. So now your question is, now that I've done this, okay, so this line here, include Iostream, allows us access to the streaming facilities. One of the facilities that is in there is this cout thing, this console out object.
Is Iostream itself a library?
Iostream itself is part of the standard library. It's one of the components of the standard library. So there are, I think about 20, 25 different components that it's split into. And one of them is Iostream. There's another one that we'll see later is called String. It gives you access to the facilities for dealing with strings. There's another one that's called Vector. That lets you deal with vectors. So there are, I think it's about 25, plus those are the C++ ones, plus there are a lot that come from C. So there's C standard out, C standard IO, C, whatever. A lot that are imported from the C standard library as well.
So you've just specifically called each separate part of the standard library before?
Yes, okay. Yeah. So it's really common to have several lines of includes to bring in different bits of software, to reuse different bits of software from different sources. So in this case, we've brought in this part of the standard library for use in our program. Was that, did you?
Well, kind of yes and no. Like in my mind, and I don't know, for example, I do a lot of Golang, for example. And in Golang, I would import Iostream, and I would do Iostream.cout. But I'm calling it. I don't fully understand the relationship between. I mean, I don't understand why I have to import Iostream, and I also have to call the std namespace.
Okay, so you said you would import IO.
I would import Iostream, and I would call them
Iostream dot
of the library that we import.
Yeah, so that is precisely what you're doing here, except that the naming is a little bit different. If this was called standard.iostream, would that make you happier?
Sorry, if it was called standard.
Okay, so because the standard library is very large, it's divided into many parts, and all these parts have their own include lines, their own headers, 25 or so of them in all. But all the standard library facilities are put in this same namespace called std. So when you're saying you would call Iostream dot something, that presumably, I don't know Go, but that presumably is a namespace or a class that you are calling into.
Imported package, that's
Yeah.
what I call it.
Yeah. Yeah, so Go has that namespacing, and it so happens that their language choice was that the name of the package is the same as the namespace name. Whereas C++, things are a little more general. The name of you can think of Iostream as a package if you like. The name of the package doesn't have to be the same as the namespace of the things inside it.
So does that mean that the STD namespace is defined inside Iostream? No.
Everything, yes.
Yeah.
I think the problem is that C++ doesn't enforce anything like that. You can do anything you want in these things, unlike other languages that if you do an import in Python or whatever, it will always put it in the same namespace as the name of the import. And C++ doesn't do anything like that. So it's just conventional for standard libraries that they all exist. That's really the thing. You have more freedom.
Yeah.
So just to reiterate, I want to get it right.
Yeah, yeah.
So I include Iostream. Iostream as an STD namespace defined
Inside it. Yeah.
So,
So
okay.
In C++, namespaces can be reopened. So I can write a bit of code that's in my namespace in this file, and then over here in another file, I can write another bit of code that's in the same namespace. Okay, so namespaces are a sort of higher level thing. So I don't know about the conventions at this company, but a lot of companies will have a namespace for their organization. Right, so if your company is called AwesomeSoft, you might have a namespace. You put all your name, all the software you write is in namespace awesome. So you'd write awesome : where you probably put it something shorter, right? You probably like AS for awesome software or something. But you could put all of your company's code in your one namespace. And then that wouldn't conflict. If you were using some open source code that came from a different namespace, then your stuff wouldn't conflict with this other code you're using. Okay, so yeah, C++ namespaces are a bit strange because, like you were saying, they have much less strict rules compared to modules and packages that other languages have. So you can think of it more as just a way of, it's almost like a prefix. So in C, what you would do is you would literally write a prefix to your function name. But that's the way standard C, the STD or namespaces work in C++. They're like a prefix. So everything in Iostream has this STD prefix. And things like the string library in string, that has the STD prefix. Everything that's in the standard library has STD as a prefix.
You're not allowed to use it.
So there's a major collection of open source libraries called Boost. It's quite famous. If you've done any C++ programming, you've probably heard of it. They have lots and lots of packages, and these all exist in the Boost namespace, the highest Boost namespace.
So is there a way to include the Boost namespace? You have to call it separately.
So you would include, and then whatever the path was to this Boost thing.
The header files.
The header file for your installation of Boost. In fact, I think one box actually lets you play with. It's got Boost built into it.
Yeah, a point to make is this included. Iostream is literally a file on your hard drive. It's just pulling in that physical file on your hard drive.
Yeah, we're getting to precisely what hash include does and why it needs this hash. I think the week after next. But yes. I know the namespace thing is confusing to begin with. Had a lot of questions about it last time we did this as well.
It's a way for people, organisations, to just organise their code. You can define your own namespace, and then you organise all your code under it. And then people using your code will address it by that name. It's just for organisation. Computer doesn't care.
So it's a bit of proprietary terminology.
No, it's not got anything to do with that. It's just for organisation. So I can have an open source project that I do for fun, and I'll put it in a namespace that I pick, Oliver, for example, whatever I want.
The function name in main. Main is in lowercase.
Yes.
Is this all very case sensitive? In other words, could main be capital M, for example?
It is entirely case sensitive, and main cannot have a capital M. It must be lowercase.
So the initial function absolutely has to be lowercase main.
Yes.
Lowercase main, lowercase int, and not only that, but all of these things have to be lowercase. The keyword has to be lowercase. It's entirely case sensitive.
If you're wondering, there is an alternative version of main that takes command line arguments. There are essentially two valid versions of main. One with no arguments, no parameters, and one that takes two parameters. If you could declare a main with an uppercase M, but that would just be a function, your own function. It would not recognise it.
It would not have these special rules.
You mentioned if it, for example, should the verbs creates a print function.
Yes.
Okay? And you wanna identify this in a specific namespace. How you can do that to identify which namespace? You need to declare the namespace to identify that print belongs to this namespace.
So to do that, there's a keyword in C++ that's namespace, and you write namespace and then the name, and then you open a block and you put the definitions in that block. We'll get to that in a couple of weeks' time.
No, because you mentioned, but in that case, the standard is inside the Iostream. So there is no declaration was implicit in that case.
Yeah, so the declarations of these things are inside this file. Yeah. So we'll see how to write our own namespaces as we go on. Right.
One more question.
Yeah.
If I wanted to check the documentation, for example, would I check documentation of Iostream or STD? And where is it? I guess there is a C++ official documentation online.
Yep. So the last slide that you'll see today has a list of online resources. Honestly, the easiest way to do it is just type std:// and the top link will probably be a site called CPP Reference, which is like, it's a reference site. It is like the Bible. It's got absolutely 100% correct information. It's not always all that easy to read. You can find like a tutorial that explains it to you a bit better, but it's like for any programming language, it's the reference documentation. So that's cppreference.com. And it's almost always the top Google link anyway. The only one I would be careful about is that there is a type in the standard library to linked list. It's called std list. Just be careful Googling std list at work, or you get a call from HR, which absolutely didn't happen to me. Anyway. Sorry? Nothing, it was a joke. Okay.
Did we ask you if you have anything you want to share?
I think sharing would be the problem. Anyway, let's move on. Save these jokes for the pub. All right, let's talk about the C++ compilation process. Because I've talked a lot about something called a compiler. And if you're coming from something like Python, this idea of a compiler might be a bit strange. So a compiler is a program that takes our source code and it spits us out an executable, a program that we can run. Right, so in Python, what you do is you write your source code being just a text file, and then you call Python with the name of your file, and then it just runs. Right, because Python's an interpreted language. C++ is not an interpreted language, it's a compiled language. So we have this program called a compiler. It takes our source code, takes our text file with all that horrible code in it, and it processes it and it turns it into machine code, something that our computer can execute, a program that we can run. So this has positives and negatives compared with interpreted languages. One of the positives is that many of our errors are caught by the compiler, are caught at the time we try to compile our program. So if you've written Python, I'm sure you'll have come across something where the program runs just fine, and then you might go to this particular option and suddenly you get this error because something's returned none and it didn't have this method. In C++, that kind of thing, that would be caught by the compiler. It would say, you're trying to call this function, but this function doesn't take this type of argument. And in particular, C++, as we'll talk about in just a moment, has quite a strong type system. So we can catch lots and lots and lots of errors at compile time, as it's called, at the time at which we compile. Also doing this ahead of time compilation, in many cases allows the compiler to do a lot more optimizations. If you think about something like, use Python as an example, you want the program to start pretty much straight away. As soon as you press enter, you want it to pop up. The compiler doesn't have a lot of time to optimize your functions. Whereas with this separate compilation stage, the compiler can spend a few seconds if it wants to, a few minutes if it needs to, really, really optimizing your software, optimizing your program so it runs really, really fast. Because a program will be compiled once and then might be run 1,000,000 times. So it's worth, well, C++ makes the trade-off that it's worth spending longer on the compilation because that's done once if it makes the millions of times you run your software a lot faster. So we like this separate compilation. We like the fact that you can get errors at compile time. Compile time errors are better than runtime errors. Runtime being when you actually run the program. In fact, C++ programmers will go to extraordinary lengths to try and force all their possible errors to come out at compile time. And going even further, sure a lot of you have heard of Rust. Rust takes this idea even further and does an awful lot of analysis of your program to really, really make sure that your program, if it compiles, it's as bug-free as possible. C++ doesn't go quite that far. We don't have something called lifetime analysis. But still, we try and get as many errors, potential errors as we can at compile time, catch them at compile time. We'll also get warnings. So warnings are things that, it's legal code, but it's a bit iffy. It's so, are you sure you wanted to do this? This looks a bit suspicious. Because compilers are really, really, really smart. Like, I'm not kidding, they are just written by geniuses. Very, very, very clever programs. And so they can recognize these patterns that are, the language says it's allowed, but you probably didn't want to do it. It's probably an indication that there's a bug in your program. So if you do get warnings, then don't ignore them. There are options to switch off warnings. Don't do that. If the compiler is warning you about something, it's probably for a good reason. There are very, very few spurious warnings, at least unless you're doing really hardcore stuff. Very few, for sort of mainstream programming, very few spurious warnings these days. So if you do get warnings from your compiler, don't ignore them. And one box that we've just used is an online compiler. So it looked like it was doing what Python does, just running the program, interpreting it. That wasn't actually what was happening. What one box does when you press the can't remember, is a button marked run or execute, whatever it's marked, it's actually doing this two-step thing. So it will be running the compiler first, and then, assuming the compiler doesn't have any errors, then it will run the program. So it's doing the two steps behind the scenes. It just looks like a single step. So schematically, at least in a simplified version, this is what it looks like. We have this magic program in the middle that takes our source file, processes it, turns it into machine code, analyzes it, and spits out an executable that we can actually run. And later on we'll see, 2 weeks' time, we'll see that this is actually a little bit of a simplification. There are a couple more steps involved, but we'll cross that bridge in a couple of weeks' time. But for now, when I talk about the compiler, it's this thing that turns your source code into an executable. Was there a question? No? Oh, I thought I saw a hand up. Oh. Okay. Been a lot of info, really. Yeah.
Is it possible to cross-compile for interest? Like if I want to compile my executable to run, I do on a Mac and I want to compile it for a Windows machine.
Oh, absolutely. Yes, there are. You can have cross compilers. I don't know about Mac to Windows. I assume it's possible. I don't know one off the top of my head, but I know that you can run a Linux. You can have a Linux machine that can compile programs for Windows, for example, and vice versa. I think for Macs, Apple are very protective, and you have to use a Mac to compile for a Mac because Apple are very protective, but certainly between Windows and Linux, you can do cross compilation, absolutely. And that's how most Android apps are written, for example, because you will compile it. You compile this program on because compiling on the phone itself is very slow, so you will compile the program locally and then transfer it to the phone to run. It's felt like a real info burst tonight, hasn't it? I'm just pounding you with information. But that's okay, I hope. I hope it's okay. Let's talk about types. Data types. So in programming terms, if someone can tell me what is a type? What do I mean by the word type? Lots and lots of people put their hands up when they said they did programming before. Yeah.
It's a form of data. So you'll either have integers as a data type, strings as a data type,
Yep.
floats as a data type.
Yeah.
It's
It's a form of data. I like that. Yeah, I think that's a good explanation. It's actually probably a bit mean of me to ask it because I actually thought that was quite a hard question. Like when I was coming up with these slides, it's like how do I introduce the notion of a type? What is a type? How do I explain that? But it's a form of data, the form your data takes. I really like that explanation. This was my explanation. Type is a way of giving meaning to some data.
It's
Yeah.
also a category.
Right?
It's data, but it's categorizing your data. It's saying this data is this category. Because in C++, you can't just make one category be another category, right? Like you categorize animals. Fish is maybe a type of, not mammal, what a fish, I can't remember. Anyway, you get
Fish are fish.
Fish is just fish.
A cod
okay?
is a fish.
Like an ape is a mammal, but a fish is not. So it's a way of categorizing your data and ensuring you can't accidentally try and use one thing as if it was another.
Yeah. So if you think about it, your computer memory, all that knows about your ones and zeros, right? bits, bytes. A type is a way of giving meaning to a collection of ones and zeros. The type of some data tells us what it represents and what we can do with it. So for example, we can meaningfully multiply two numbers. Integers, real numbers, whatever they might be, complex numbers. We can meaningfully multiply numbers. That operation means something for numbers. But multiplication doesn't mean anything for strings. How would you define multiplication of two strings? I can't even think how it might work. You could probably define addition for strings if you wanted to. You just concatenate them together. But defining multiplication, yeah, I don't know. And this idea of type can seem a bit strange if you come from a, background in other languages that doesn't have this very strong idea of types. But really, it's something you're already familiar with, even if you don't know, because you've all got a computer in front of you, and you're already really familiar with this idea of file types, I'm sure. Because on your hard drive, your SSD or whatever, or in the cloud, whatever it is these days, all that knows about is ones and zeros. But you're already familiar with, okay, this bunch of ones and zeros, that's an MP3. And this bunch of ones and zeros, that's a Word document. And this thing over here, that's a JPEG. These are different file types. And the type of it tells the computer what you can do with it. So if you try and force it to open a Word document as an MP3, it's not going to work. Right? The computer's going to go, oh, that's an error, I don't understand, that's not right. Right, so this notion of type is something that sometimes, as I say, people coming from other languages are a bit surprised about, but it is something that you're already familiar with, just from using your computer. Guys, do you mind? So C++ has several types built into the language. So we've seen ints already. An int is an integer. It's a whole number. We also have floating point numbers. These represent real numbers, so numbers with decimals, fractions. Those are floats and doubles. Has this Boolean type. Bool can either be true or false. There are several of these built into the language. And then the standard library has lots more that we'll be using through the course. The most useful are a standard string that represents, as we said, some text, and a vector, which is a collection type. It holds a collection of some other type. So a vector, you can have a vector of ints, or a vector of floats, or a vector of bools. Don't have a vector of bools, but yes. And the language also provides us with tools to define our own data types. We have structs and classes and enums, unions if you really must, to define our own data types as well. So this notion of type is really, really, really important in C++. Absolutely kind of fundamental to how it works. Because C++ is what's called a statically typed programming language. And this means that every variable, every bit of data that you use has its type determined when the program is compiled. Not when it's run, when it's compiled. And the reason it's determined is because you tell it what the type of this data is. Or you tell it to work it out for itself, as we'll see. But the type of all your variables is determined when the program is compiled. And this type safety that C++ has means that we can catch many potential errors. This compile time error thing I was talking about. This type safety is what enables that. So if we tried to multiply an int and an int, that would be fine because they're two numbers, we can multiply those. If we tried to multiply an int by a string, well, the compiler would tell us you can't do that. We get an error at compile time. Whereas in a more weakly typed language, we might end up with a situation at runtime where we were trying to multiply two things, but we wouldn't know until we actually got into that situation. We'd have to go through all our testing and hope our testers found that. Whereas in C++, we'd get that. Our program, we wouldn't even be able to form a program. That would be an error. The compiler would not run, would not finish generating an executable. There are various ways around the type safety, ways you can poke holes in it. Typecasts being the most obvious. These are bad ideas. If you're using them heavily is an indication probably that something is a bit wrong with your design. So try and avoid working your way around the type safety rules. They're there for a reason. So the way around it, it's a bit like if you ever try changing the file extension on Windows, and suddenly Windows thinks that a file is a different type to what it originally was. That's a bit like what a typecast does. It's saying to the compiler, no, I know better than you. And, well, you probably don't. So the notion of type, really, really important. Every bit of data in your program has a type. And that type is established when your program is compiled, and it can never change. Is that clear, or is that? Yeah? Awesome. Any questions about what types are and why we care? Yes! All right. The last section for today. Let's talk about functions. So C++ programs are composed of functions. A function is a piece of reusable code. Function really is just a list of instructions. And when we enter a function, we execute the instructions, and then we get to the bottom or we get to a return statement, we leave that function. And we've already seen one of them. We've seen the main function. The main function is special. It's the one that we begin our program execution in. But of course, we can write our own functions as well. And just a little note, again, for people who've seen this before, or seen some C++ before, there are two kinds of functions. We have member functions that belong to a class, and we have non-member functions that just exist. They're freestanding, they're on their own. We're not going to talk about member functions today, or not for a few weeks actually. We're going to talk about freestanding functions only. So if you know what a member function is, that's great, but you don't have to use that knowledge just now. So, the way we write a function, the way we declare a function, the way we say, here is a list of instructions to execute. We write the function name. A function name is hopefully a reasonable or reasonably short description of what it does. Write the function name, and then we have a pair of round brackets. And in these round brackets, we write the arguments that the function takes. That is, the data that we put into the function. The data for that function to operate on. And we can have as many of those as we like. Well, in theory, there's some upper limit, but it's like well over 1,000, so don't worry about it. It's a bigger limit than you'll ever hit. We can have 0, 1, 2, up to as many as you like, arguments, that is, pieces of data we're sending into the function. And we can give each of these pieces of data a name, a parameter name, and we also, very importantly, have to tell the compiler, have to tell the computer the type of this argument. So this notion of type is very, very important. We have to, for each piece of data we're giving our function, we have to tell it, we have to say what is the type of this data. So we have a function, we give it some data, and then we probably want it to do something, to operate on that data, and perhaps optionally to give us a value back, to give us some data back. And if it gives us some data back, of course we need to know the type of that data that we're getting back, because type is so important. So we need to know the return type of the function. So this is, again, if you've used Java or C or any of these sort of C-ish languages, this way of writing function definitions, function declarations, will be very familiar. Every function in C++ returns 0 or 1 values. So we can have a function that returns nothing, doesn't return anything, or we can have a function that returns 1 value. We can't return multiple things at once. Some languages let you do it, Python does, I think Go does. In C++ we can't. We can only return one thing or nothing. And if a function does not return anything, we put this special word void in here. So we write that our function returns void, returns nothing. I don't know why they picked the word void, that actually came from C. It's a bit of a strange word to use, but yes, that's the word. It means nothing. It means this function returns nothing. Oh yes, also, just for if there's anybody who's familiar with C, one slight difference between C and C++ is if the list of parameters is empty, in C++ that means the function takes no arguments, whereas in C it means something different. So in C++ it does what you think it should, which is if the list of parameters is empty, that means this function takes no data. We're not giving this function any data.
I think the difference was that in C, empty parent means var effectively.
Yeah,
basically. And in C++, use ...
So that's the kind of theoretical side of things. Let's have a look at a real definition. Okay, so what's the name of this function? Add. Yeah, absolutely. And how many parameters does this function take? 2. Yeah, so that is great. It takes 2 parameters. They're named A and B. And they both have type int. And the return type of this function is int. Absolutely. And the language has a built-in plus for integers, as you might expect. Does what you might expect. So all we do is we return this value. So we're saying we return an int, and then after the return statement, We're telling it which value this function is returning. This function does not return 0. Well, if you gave it a and b, if a and b were both 0, then it would return 0. But this function just returns whatever a plus b is. So if you gave it 3 and 6, it would return 9. So it's only the main function has this special ability of returning 0. In this case, we're just returning whatever the sum of these two numbers is. If you gave it 1 and minus 1, you get 0 anyway. So, ooh, magic disappearing code. My slides do this from time to time. It doesn't happen when I preview them just on my screen. As soon as I plug it into the projector, for some reason my code likes to disappear. I can only apologise. I blame Apple. It's their fault.
It's like playing a chess, blind chess. The pieces disappear.
Yeah, exactly. So, as we said, this defines a function called add, takes two parameters named a and b, they're both ints, and it returns an int. So that's how we define a function. That's how we write in our source code that this piece of functionality exists. But how do we actually execute that? Executing that is called calling a function. So we call a function by giving it some data, if it takes any parameters, by giving it arguments, and then the execution will jump over to where this function is. It will run those instructions till it hits return, and then it will come back to wherever we called the function from. And the way we write that is by writing the function name and then the arguments we want to give it in brackets. So to give you an example, here I've used this add function we just defined. So here, imagine add was written up there somewhere. And now I've said add, and in brackets I've said I want to add 3 and 4. So again, if you've done any sorts of programming before, this will probably be very familiar. And then this standard cout business, this is printing, as we were printing before. So we're printing the result of this function. So this returns an int. So we're passing that int to the output stream. And then once that's done, we're printing a new line as well.
So what's the name of that print 7?
Sorry?
Print 7.
Print 7.
That's a comment.
Yeah. So this bit is just a comment. That's just me telling you what that function is doing, what the result of this line is. So this part, after the two, it's hard to see on this screen. It's actually in a different colour, but that part after the double slash, that's just a comment. That's not actually C++ code.
So whenever you call a function, do you have to do that
No. So this part in the middle is the function call. This is calling the function. This \n actually, you know what? That's unnecessary and confusing, so I'm going to get rid of it. There we are. That's better.
So Tristan, I know you just removed it, but why did you have the double arrows when you have the...
Okay, so what that was actually doing, so these output streams are sort of magical in that you can pass lots of things to them in a row. So what we were doing is we were passing the result of this, and then we were passing a new line character.
So do that every time.
So you can. It's why it's called a stream, because you can stream lots of things into it, one after the other. But it was probably unnecessary to have that now. It was a bit of a distraction from what the main point was. So yes. So we can just have this takes the result of this function and passes it to the output stream. So this is something that's a bit different. It's a relic from the past in many ways. But in C++, we have to have declared our function before we can call it. What do I mean by that? It means, oh God. So what happens is when we get to this line, the compiler needs to know what add means by the time we get here. So we have to declare our add function physically above where we actually use it. Right? This is a very strange sort of thing that is kind of unique to C and C++, and it's kind of annoying. But you do get used to it after a little while. But when in order to use a function, its declaration has to appear physically above where you use it in the source file. So what this means is that typically main uses lots of other functions. So you usually place main at the bottom and you place your other functions at the top. Is there a hand? No? So yes, in most other languages, or not most other languages, in some languages like Python or Ruby or something like that, you just have a source file, and execution begins at the top of the source file and continues till it gets to the end, or you have an exit command or whatever. That's not the way C++ works. In C++, execution begins in your main function, right? But then if it calls another function, then it jumps up there. And it runs that function and then comes back. So whereas something like Python, you have all your instructions in your whole file, in C++, the functions, the instructions are all within the main. All within main, but main can call whatever other functions it likes. And it usually does. Usually people like to keep main itself quite short and have the functionality, in other functions. So having just heard all about functions and how to write functions and how to call functions, I'd like you to have a go at this. So hopefully you've still got one box there, you've still got one box open. I'd like you to write a function that looks like this. So what's the return? What does this function return? Nothing. So its return type is void, it returns nothing. What arguments, what input data does this function take? Sorry? Nothing, no. So these brackets are empty, so we get no input data. And if you think about what I'm asking you to do in this function, well, we don't have any other data that we're bringing in. We don't have to return anything. So all I want you to do is to, inside it, print hello C++ London U.
So we're not doing the Thursday to come. So it's increase on. So that's the day. That's all right. Can a function be a type? Yes. Can it be used as a type to pass to a function? You can't pass a function pointer. Yes, so yes, the function has a type. You can't pass a function to the address. That's getting a bit more.
Yes. So I wrote obviously the function wide and obviously left out. Return. No, this.
Got it right somewhere. Oh, sorry.
Because I was
You
thinking
I
that
see
you
what you're trying to
so you put it in main, you call it in main, and then you
you got it right somewhere else. It should be in
the things, the Iostream passing through. This is calling that. This is the call. This is so understood how to call it because that's the function. You can't do anything with it. That's just a reusable method. You have to call it somewhere else.
Yeah, so you are calling it, trying to pass the result to get rid of this.
So you just call it hello C.
It's the output. The operator. Well, if I took an int, so just like
Yeah, maybe so int.
then down
Yeah, to well, you put that as a parameter.
yeah, so we can get it.
Then what the Wi-Fi code?
Thank you.
Yeah. No, that's a string. That's just a string. Okay. Need to check function. Just print that out. If you've done it correctly, you won't actually see that.
Okay, so that's
Code return function. The output will just say hello C++. So you start by
Usually it's right in the destroyed.
no, that's a string. That's just all you can play. It's just a string that happens to like subset. Create a function like
So what did I miss?
scroll up
Because what I've done, what I did,
you see how this function made, right? So in front of main, for main, we've changed it. So yeah, it returns. This makes up so somewhere in this blank space, main is a function. Now all hello but it should be it. The example for this is this thread. The same logic.
so basically I just copy that word and it's
This is saying to understand what it means. If you don't understand, you just copy it. So it is a function, that's what we call it. Its name, we've decided, is hello C++ unit, right? So we make that with people who doesn't care. It's a unique one. So it returns nothing, we give it back. And it's taking on brackets. Yeah.
the right click run them.
You now give it a body. So the function has a name, it has a list of arguments, and then look, it turns off, its name is main, it takes no arguments, and then these curly braces, so its body is code it actually executes. So now these curly braces, and then inside those curly braces, write the code that actually runs. So main is just write strings to see out on its main.
So what do I need to do?
So you create a function, body of something should split close.
This body, right? So I need to insert it.
No, that's not. Oh, it's got curly braces. You see that on line 6 and line 7. Stuff inside those is inside them. The actual code adjustment. That's a
But actually I did something just before you came. But I got errors.
okay, so give it enough code, and then how we get it.
Okay.
Cool.
Because we record every single one, because I saw you have a few lessons there. I subscribed already, because I saw lessons. But let's say, what is going to be the second lesson that you record all the time? So you recorded this one. So I can see live.
Join us. I can watch this. Participate us like here. People are asking questions and so on. Answer questions. You can see at the same time zone where you can't. And you can just watch it later on the record session. Yeah.
Okay, it's gone 9 o'clock, so we very
so in this function, we ask you to print the whole function. But reality is so if you only return something like a C calculation or a math,
when there's a calculation of something needed. Okay, guys, it is 9 o'clock. It is time to be going because the pub beckons. So lots of you have been successful with that, which was great, which is awesome. This was my solution to it. This was my solution to it. So we have this function, hello CPP London Uni, takes no arguments and returns nothing. And all we're doing in here is we're executing this print statement. And then we have our main function, and in main, we just call this function. So this is the function definition, and this is the function call. And if you want to, you can put return 0 underneath there. As I said, in main, the return is optional, in main only. But yes, this was my solution. So, as I leave you, these slides will be on GitHub tomorrow. If you've joined the Slack, I'll put the link up. Otherwise, if you want to take a picture of that, you're welcome to. We'll just make things a tiny bit more complicated. So now I want you to write a function which takes an argument and then pass that argument and return it again. Return it differently. So instead of dealing with functions that return void and take no arguments, now I want you to deal with a function that takes an argument and returns an argument. And we're using this type string, like std string. So this is homework number 2, and if you manage this and you're very enthusiastic, then if you check the slides, there'll be another little homework exercise as well. And if whoever's meeting up on Thursday, you can have a crack at doing these together. Yes, but I don't want to flick to it because it'll flick past the answers.
Oh, okay.
All right, there you go. Haha. All right. Sorry? The Slack channel. Oh, yes.
It's you type the email and it will send the invitation.
The Slack channel is the second one from the bottom there.
Excuse me.
Okay, thanks everybody. Big thank you to Tristan for an amazing class. I hope I will see you, or some of you, on Thursday, which is in Costa Cafe. So basically we'll be sitting somewhere on the back and come and do some exercises with us. And now, anybody who is willing, let's go to Beershanke. Join us and we'll go there as a group, drink a couple of beers, and then everybody should safely get home and be ready for tomorrow. So thanks very much.
Tells the meeting again.
No, Costa Cafe. Look on our website.
Costa Cafe.
Yeah.
Yes.
Can you take me to the answer for the exercise?
For exercise 2.
Yes.
Yes.
If anybody wants to take any of the drinks home, feel free. Except the big glass bottle, obviously. Or the empty glass.
Yes.
I can't remember what the include file is that I need.
Oh, okay. So
Yeah, as far as I know, it's plastics.
Yeah.
People make something special. So I'm not a fan.
This is automatically done.
Yes, so that's Visual Studio, isn't it?
VS 2017.
Oh, the newest one. Okay, so we're. I don't think we'll do it next week. We'll do it the week after. We'll go through installing an IDE and everything. So you're a little bit ahead there. But
I've had to do some, don't ask,
yeah.
some serious stuff recently, but I'm trying to get the basics. I know this sounds completely
If you're a Perl wizard, I'm sure this is no problem at all.
well, okay, don't go there. Having said that, do you cover Visual C at all?
Visual C++. Yes. Visual C++ is a sort of Microsoft brand name for.
I know.
So they're actually very, very heavily moving towards standard C++. So
the visual thing about it is you can produce a window.
That's no. well, not using Microsoft. We have done a bit in the past using a framework called Qt, which is like multi-platform, but specifically Microsoft, no, because, well, I don't have the background for it. And,
Okay, fair enough.
as you can see, I use Macs.
Yes, I can see that, but then again, there is VS C.
Yeah, well, I think
C++ for Mac.
the Windows Form stuff is specific to Windows. I don't think so. This uses a Cocoa display thing. Hi.
So, about the JetBrains, I can use any text editor, or you prefer everybody use the same?
Okay, so you can, if you want to, if you're happy, if you're comfortable using it, you can use whatever you like. We recommend, if people aren't familiar with it, if they don't have their own preference already, using this program called CLion.
JetBrains, the website.
Yeah. The reason for that is that it works on Windows and Mac and Linux, works everywhere. It's very powerful, comprehensive. It does everything you need to do. It's got very good like tooltip support and all of that. And we kindly have a free license for it. And it just makes it easier for us to offer people help. You know, if
It's one thing.
yeah, because I don't know Visual Studio very well, so somebody's coming.
No, I use Atom because I do a few things.
If you already are happy using Atom and you have a C++ compiler for Atom, then
Yeah, pretty
go
much
ahead
I do on the terminal, so it's not.
Then, if that's what you want to do, then go ahead and do it. Yeah, it's not mandatory using CLion. We just recommend it if people don't have their own preference.
Oh, okay. And how works at the end? I saw something about the testing, the exam, in other words. How that works? Is a project or pretty much just
yeah, I
basic
mean, we're a little way away from that.
Yeah,
now,
but just
yes. So the way it works is that we give you, once we've got enough people who are interested and we feel at the right level, we give you a week-long project to do at home, and then you submit that. We take a look at it. We sit down with you and have a bit of a chat about,
no, because I have a few ideas. That's why I'm asking you.
Yeah.
Because I saw you somewhere.
No problem. Are you coming for a drink? I hope everybody is, right? Everybody's coming for the pub.
I don't have my ID.
Oh.
But I will.
Yeah, neither do I. But
Yeah, because I have a few things in mind, so that's why.
and for projects.
Yes.
Oh, that'd be cool.
Because pretty much I'm in Cuba. I try to learn about blockchain.
Okay.
So I have a few ideas to do. So because pretty much we're basic or Hyperledger or Ethereum. So maybe a bit crazy, but I would like to do something to cover both.
Okay.
Maybe I know it's a far away.
I don't know a lot about those, to be honest. So I'm not sure how I get on writing a.
No. But I mean, because I have a project.
It would definitely be an interesting thing to do.
Games, because I have twins, little ones. When they take their pad, my God, forget it. So do something for them as well.
Yeah,
So
definitely
that's,
something like that. So our last assessment actually was to write a little blackjack game, not for toddlers maybe, but just to implement that. So you could play blackjack against the computer. That was.
Ah, okay. No, just have an idea how it's going to work. Thank
Very
you so
quick
much.
question with calling functions.
Yeah.
So if in this function, if it was, say, let's say you're doing a calculation,
Yes.
and took ints or whatever, made floats or whatever,
Yeah.
would you have to call it with a float or int here, or because it's already initialized as a float,
no.
you just pass the parameters in?
Exactly. The second one.
Okay, so you just pass the parameters, and you can have the comma separating the number of parameters.
Yes.
But you don't need to initialize the parameters in here either.
Correct. Because you already know what
the function, because the function's already been defined what type it is. Okay, cool. Thank you.
Awesome.
Hello.
Hi.
I think you teach the well.
Oh, thank you.
And I have a question. I'm sorry for late.
Oh, that's fine. That's fine.
Yeah. I.
Sorry? You can just leave it
Yeah,
here. 'cause
I'm sorry about
No,
that.
no problem.
And on the Thursday we have the practice about the C++.
Yes.
So it's not the course like this.
It's not like this, no. It's in a coffee shop. Just a few people with their laptops working on the homework. So it's not me like this. It's just quite informal. It's you don't have to go. It's optional.
Okay, so you are temporary teacher for this class, or this class you always.
So it's always me. It's every Tuesday. So me talking is every Tuesday.
Yeah, okay.
And Thursday is there's like a group, everybody working on their laptop. So Tuesday is me talking, Thursday everybody.
Yeah. So how long this class will continue?
Because they're closing at 8.
Forever.
For hours.
Well, we try and cover. So we'll do sort of 8 weeks of material, maybe kind of basic material, and then we'll go on and we'll cover. We'll probably do another slightly more advanced, maybe like an intermediate level course, and after that, so we're trying to do kind of modules. So this is the introductory module, the initial module, and then we'll do a like more advanced module, and then we'll do kind of more specific little parts of functionality. So we'll do an object-orientated module, or a module on templates, or a module on different parts of C++. So we will continue as long as people keep coming.
Oh, really?
Yeah.
Thank you.
No problem.
So the next, so the Tuesday, Thursday, the price will on the meetup.
Sorry, the Thursday.
The price.
Yes.
Will on the meetup.
That will be, if you look on our website, cpplondonuni.com. So in the last page PPT shows that website. I hope so.
What I was talking Ollie, about.
Noise.
Yeah, I've got it. Sorry.
What I was talking about the events.
So this is right.
So our one is.
Ollie, what do you want to do with empty boxes?
Sorry, we have to go.
Sorry.
That's okay.
Sorry to take your.
No. Pen.
Oh, pen.
There's one here.
Oh, hello. Did you come to learn C++? You missed it.
So that's our website, cpplondonuni.com, and that has all of the dates of all of our
Thank you.
No problem. I hope to see you next week.